Hi friends, welcome back to this new episode. In this, let us see how a node can be deleted from a doubly linked list. So we have totally five options. One, the node may be the head of the doubly linked list, or the node may be before any given node, or before any node having a particular key. The third possibility is the node we wanted to delete maybe after a node having a particular key, or the fourth option maybe we want to delete a node at a particular position in the doubly linked list, and finally we would like to delete the last node of the doubly linked list. Let's see one by one. So to begin with, we just try to see what is required when we try to delete the head node. So whenever we are trying to delete the head node, so first thing we should see that the second node does exist, and if the second node exists, then call it head, and its previous make it a null, and later we need to delete this node or the memory allocated for this node to be deleted. So, but once we move our pointers to the second node, then we won't be able to find out where the first node was as to delete them. So before that, so just remember this node as a temporary node, and then make adjustments to the second node, as second node is the head and the previous of the second node is the null. So then delete this temporary. So code, let's check it. So here we are trying to delete the head node. So this all operation is possible only when there exists some doubly linked list, or there is a node with a name called head. If it is null itself, then we don't have to do anything, just return back. Otherwise, this first node, what is called head, is stored as a temp. So address of the first node is saved as temp, and then the heads next will be called head now onwards. So heads next is the second node, and second node from now onwards will be called the head. And if this new one does exist, then its previous should be called null. And then free the memory allocated for the node which was called as temp, and return the head back. So that's what we are supposed to do when we are deleting the head node. So let's check what would happen if we are working on the deleting the head. Yeah, so we have the code here. As discussed earlier, we create a node. For that, we have a node data structure defined as a structure with three components: data, previous pointer, next pointer, and so on. Then to delete the head, you just check whether the head is null. That means doesn't no doubly linked list exist. Otherwise, the address of the head, just temporarily remember it as a temp, and then heads next, the next node of the head, that means the second node, is now onwards will be called head. And if the second node does exist, then second node's previous node will be called null. That means the link to the previous will be null. So we just say that. So if we are moving in the reverse direction, we don't have any more node before what we call head. And once we have done this, then we free the memory allocated for the temp and return the head. So to check that, so we have a function to create a node. So we create a node, we call that head with a value 1. Then we create another node which is supposed to be the heads next and give a value 2, and the heads next previous will be head itself. So we make the proper links, and heads next. So we are creating the third node in the line. We give a value 3, and then we connect the third node's previous as the second node. So just before deleting, just check what is the status of the doubly linked list, and then we delete the head, and then check the code again, and then let's just run this and see what we get. So we had inserted 1, 2, 3 as a 3 nodes, and after deleting the head, this 1 disappears. So 2 becomes the first node. So 2 and 3 will be the 2 nodes we have in the doubly linked list. So we can modify this and just check that this can be 10, can be 20, can be 30, and see what would have happened. So we have 10, 20, 30, and after deleting the head, we are left with 10 and 20 and 30. So yes, that's working. Now let's get back to our next one, where we are looking for deleting a node before a node having a key element. So in this case, the key element is 3. So before 3, whichever node comes has to be deleted. So deleting that means this node we have to reach, and the previous node to that, and next node to that. We need to use the two nodes, and next of the previous node should be the next of the next node, and the previous of the next node should be the previous node, which one we are trying to delete. So this two connections we have to make. So let's just look at that, how that is done. So the current node we call it head, and then if the list exists, then we just check whether the current data is what you are looking for. We are looking for key 3, then we are here. Is it 3? No. Then go to the next one. Is it 3? No. Then go to the next one. Is it 3? Yes. Then break. So when we reach this point, we break it, and after that, we just check that. So is this, does this exist or not? If yes, or is this the first node? So if it does not exist, or if this is the first node, then we cannot delete the previous node. So just return the head. Otherwise, this is the node where we have reached. This is a value with key. So let us define the node to be deleted as node to delete as the current node's previous node. Done. So now we have this as a node to delete. So current node's previous should be node to delete's previous. So its previous is this one. So we made this connection, and then we need to make this connection, that is to be done by the node to delete's previous. Its next will be same as next of node to be deleted. So node to be deleted's previous is this, and its next will be the current node. If this is not null, so if it is null, then that itself is the head, and then free this node to be deleted, and then return the head. So that's these links to be created, and then this memory has to be freed. So let's check the code for that. So we are trying to delete a one before. So here we are trying to say that we are deleting the node before the node having a key. So we start from the head, then we look for the key, and for moving, so we define a pointer to the head, and then as long as we don't get the key, we keep moving forward. Once we get the key, we break there. That means where we break is the current node, and if the current node is null, that means we have reached the end. Or if the current previous is null, that means the key where what we are searching is the head itself, therefore just return that as the head. Then the current node's previous node, you call it a node to delete, and then make these arrangements, and finally free the memory. So to check that, we have created a node 1 called head, then its next one we called 2, then its next one we called 3, and its next one we called 4, and this previous connections we have made to make it a doubly linked list, and then we print before the deletion, and after deletion we print. So what are we deleting is the node before node having a value 3. So the doubly linked list created is 1 2 3 4, and we are trying to delete before 3. That means 1 2 3 4. Before 3 is the node containing value 2 should be deleted. After deleting we should get 1 3 and 4. Just check that what we get by. So 1 2 3 4, and before 3 what we have is 2. 2 is deleted. Now we are left with 1 3 4. So if we just talk about want to have a 30 and want to delete after 30, so we should get again final output to be 1 2 34 and 1 30 and 4, or so instead of before 3, if we say before 2, if we delete, then what we get. So before 2 was 1, so 1 gets deleted. So this is 2, 3, 4. So this is similar to deleting the head. Okay, that's about what we have for the deleting before the any given node. So we have some more delete actions, so that we look in our next session. So till then, take care. Thank you.